Okay, let's get started. Okay, let's get started, please. Can we quiet down very quickly? How fast can you do it? That means no more talking. How fast can you do it? That means no more talking. That means no more talking. Okay, so mastery exam. If you have an 80, 100, or 90, that means you are passed and you're done. This is on announcements. If you still have a 0 or you don't have a score on Blackboard for the mastery, then you have to take it again. Okay, and you can do that in my office hours or Cerny's or Morgan's. Not anybody else's, just those 3. I have all the exams. If you want to see your previous exam, you have to find me or coordinate with us for me to get the exam to the right person. Are you in our class? Oh, no, you're fine. You're fine. If you're in our class, just to tell you to come down. Okay. All right, so, let's see. Anyway, I have all the exams, so if you want to see your old exam, you have to come to me. Otherwise, myself or Cerny or Morgan's office hours for attempt number 3. And that has to be before Thanksgiving break, okay? And this is on Blackboard. Any questions on that? Okay, we're going to press on. If you still have questions on the related race problems, then you get to our office hours and get help, okay? We're a little bit behind because of Veterans Day. That ended up on a Wednesday, and so that was put us behind. So we got to press forward. And we're going to start talking about coordinating. Yes, sir.
Do we have class both Monday and Wednesday?
We're going to have class Wednesday. Yep. We will have class Monday and Wednesday. Okay, so we're going to start talking about coordinating information about an accumulation function or an amount function and its rate of change function, and talk about aspects of that. What happens is, it seems like it's going fine, right, for you, the student. Everything's making sense. And then we start talking about a little bit further, and all of a sudden things start getting jumbled, and then like nothing makes sense. Okay, this is what happens when we start talking about this. So here's the key. It all goes back to this. I'll put this at the top of the screen. We'll make it bigger. When a function's values decrease, when a function's values decrease, what can you say? The rate of change is? It's a negative rate of change. Why? Because for a little change in x, we get a negative change in y. Negative change in y means decrease. Yes, thanks. When a function's values increase, so for a change in x, we get a change in y that is going up, right? Or positive, so the rate of change is? This is our bedrock. When things start getting confusing, you have to go back to this. This will usually get you out of a jam. These facts, and we've talked about this, and you know this, right? But here's the thing: that function that I'm talking about could be any kind of function. It could be an accumulation function, an amount function. That original function I'm talking about could be a rate of change function. When a rate of change function's values decrease, say it's r. When the function values r decrease, then the rate of change of r does what? It's negative. If a function r, its values increase, then the rate of change of r is positive. It's the same principle. It doesn't matter what kind of function I'm talking about originally. It could be accumulation, amount, or it could be rate of change. This still holds. So I'm going to leave that at the top of the screen. I'm going to leave that at the top of the screen throughout the class. Okay, so here we go. All right, so over here you see I have some function, you don't know what it is, and I'm calling the function r the rate of change of that function f. And here I'm showing you values of n increasing from -4 to -2.5. So I think it's negative 2.5 is going to start over. And the corresponding rate functions as n increases from -4 to -2.5. Okay? So I want you to observe what's happening to the rate and conclude also then what's happening to the, some more room here. So you're going to be looking at the rate for this interval from negative, we're going from -4 to -2.5. And by observing what the rate of change does for those x values, make conclusions. So here's what you're going to do. R of x okay, what's R of x doing? And then therefore, what is f of x? So let's do the first one together. Okay, we're going to do the first one together. What do you see R of x doing there? As the value of x changes from -4 to -2.5, the rate of change function, what can you say about the rate of change function? The rate of change function stays constant. Do you agree with that? The rate of change function stays constant. No, definitely not. It's changing value. So as we go from -4 to -2.5, tell me something about the rate of change function. It's going down. It's decreasing. Can you tell me anything else about it? It's positive. So we could put those two things together and say that Rx gets what? We're putting both together. So it's getting less positive, right? So it's decreasing and it's positive. So it's getting less positive. So it's decreasing. And if R decreases, if R is positive, what can we say about the function then? So now it's positive, right? It's getting less positive, but it's positive in that whole interval. Is that right? So what about the function? He said it's increasing. Agree with that? If a rate of change function is positive, what about the function? Increasing. So f of x increases. Did you catch it? Okay, so that would be for what's happening in the first interval. We've got a positive rate of change, and therefore our accumulation is increasing. But we also noticed about the rate of change that it's getting less positive, and we'll talk about that later. Okay. So next interval is from -2.5 to -1, and you're going to do it. Ready? Go. Talk. Talk. There should be half of you should be talking. What's happening? Sorry. Okay, so in this interval, what can you tell me about r? What happens with r in this interval? It goes from being positive to negative. At first it's positive, and then it goes to negative, right? So, and so it continues to get less positive like the first interval, right? And then what happens? It changes to, and when it's negative, what's happening to it? More negative. And overall, what does that mean about the rate of change in this whole interval? What can you say? Decreasing the whole way. There's two ways a quantity can decrease. It can get less positive or it can get more negative, right? Those are both decreasing descriptors, right? Both decreasing descriptors, yeah.
I'm a little confused with the first one. If the value is decreasing,
Yep.
why is it f(x) increasing? If it says the function value decreases from 4 to 2.5.
No, that's x. The interval is x from -4 to -2.5. That's x. Okay, so we looked at y and we saw it was always positive and decreasing. Because the rate of change was positive, the function is increasing. That's the second statement up there. It was always positive through there. Regardless of whether it was getting more or less positive, it was always positive, the rate of change, and therefore that function is increasing now. You see now? Okay. Now here, Rx, so the rate continued to decrease. It got less positive to 0 and then started getting more negative. So tell me about the function f, if it's let's say accumulation function. What can you say about the accumulation function? At first it increases. That's when r was what? Greater than 0. And then it changed to decreasing. Where you told me it started getting negative, right? It was negative. Okay, next interval. Is it making sense so far? Are we good? -1 to 0.5. Go. So here's -1 to 0.5. Okay, what happens at first? So I heard one person saying more negative. I heard one person saying less negative. -5, -6. At first it gets more negative. Do you see that? It goes from -5, it goes all the way to about -6.3. And then it starts getting less negative. So it's more negative. And then changes to, but it's always what? Always negative. Therefore, the accumulation function decreases the whole way through here. Is it okay? Next interval. Last one, from 0.5 to 2. Here we go. Go. Maybe. Now go. Okay, what do you see here? What happens first? I heard less negative changing to more positive. Okay. First, those rate of change values are getting less negative. And then getting more positive. So then what about the accumulation function in this interval? What about the accumulation function in this interval? He wants decreases, then increases. Agree with that? Yeah, when the rate of change is negative, accumulation's going down. When the rate of change is positive, accumulation's going up. So it will change in this interval. So wherever the rate is less than 0, the function is going down, decreasing the function values. And then wherever the rate of change is positive, okay, so based on this, all this information now from -4 to 2, can you sketch the graph? Can you sketch the graph? So he's going like this. Can we be more specific? All right, so do it. So sketch it. So does the gray show up on the screen? Good enough. Okay. All right. So how about in the first interval? In the first interval, what's going to be happening there? Increasing. So we're sketching the accumulation function. So now, where do I start? Where do I start? Do I start up here in positive territory at like 1, or this is 5 actually, 10 down here? Where do I start? Go with 10. Is that valid? Go with 10. It is valid. Why is it valid? What information do you have? You only have information about... No, but that's the rate. That's the rate. Does it have to be... Can I start down here? Can I go with -10? Why? We don't know anything about the value of the amount or the accumulation at -4. There's no information about that. All you had was the rates. I didn't tell you where it was. So at -4, the value of the function f could be -100, or it could be 1,000, or it could be 0. There's no information. I haven't given you any information about the amount that we have. I only gave you rate information. So it could be down here. It could start at -5. So I'll just start there. And what's the graph going to do in this first interval? It's going to go up. It's going to go up. So how it goes up, we're not as interested in right now, but so it's going to go up though. And then as we get into the second interval, then what's going to happen? Keep going up, and then turn and go down. So it's going to hit a high point, right? Because if it keeps going up, and then starts going down, there's somewhere that's hitting a high point there, okay? What happens in the next interval? It goes down, right? And then in the last interval, keeps going down until... And so somewhere in there, it has to hit a low point. If it's decreasing and then it changes to increasing, there must be a lowest value, right? So it hits what we call a minimum. Something like this, increasing in the first, then increasing more, but then decreasing through the third, and then in the fourth interval, decreasing and then increasing again. Something like this. All right, let's see how we did. Maybe. So we don't know how this could have been anywhere in terms of up or down because all we knew was the rate information. We didn't have anything about at a particular x value. We knew how much the amount was, or we know how much had accumulated. Okay, so how did we do? We did good. Okay, so now let's talk about. So any questions on that so far? Any questions on that so far? So we'll look at that same graph. This is the same function and rate of change function. So the red is an amount function, or it could be an accumulation function. All right. But so and then we talk through the rate, and you've still got the rate there, showing the rate as it changes as the current value of x increases from -4 to 2. Or -3 to 2, or something like that, okay? So, question 1, where is the accumulation, f of x, decreasing? How do you know? Give 2 different reasons for where is the accumulation decreasing. Give 2 reasons. Go, talk about that. Okay, so volunteer. So where is the accumulation f decreasing? And so whenever we talk about where, we're talking about for what x values, over what intervals of our independent variable x values, where is the function values decreasing? Yes, sir. He wants -1.5 to 0. That's where the accumulation is decreasing. Agree with that? Okay, how about in the Arizona State sweatshirt? What do you think? From -1.9 to 1. The values of f of x are decreasing. Yes? So if you're looking for where that function is decreasing, what are you looking for? So here are two different things. A negative rate and it's going down, right? It's going down. So you're looking at the accumulation, you're saying, oh, it's decreasing, it's going down. Or you're looking at the rate of change, and you're saying negative. Those are the two ways you can know. And so this approximate, she said negative 1.9 to about 1. Is that what you said? It's pretty good. Pretty good. I mean, because we can't really see exactly. But yeah, somewhere around here, about negative 1.9 to maybe 1.2 or something, 1.1. So let's mark that off. So from about here to here, and again, the two ways we know that are, first way is, what are the two ways we know that? A negative rate of change for those x values. The rate of change is negative. How else do we know it? It's going down, right? It's heading down, right? So from one point to the next point is always has a lower y value than the previous one, right? Each subsequent point as x increases has a lower value than the previous y value. Okay, new question. Where is the rate of change? R, decreasing. Remember, there's two ways that something can decrease. How can something decrease? It can. We talked about this earlier. Two cases for a quantity decreasing. Getting less positive or more negative. So if we're asking where is the rate of change decreasing, we're asking where is the rate of change getting less positive or more negative? For what values of x? For what intervals? Go. Go. Okay, make sure you got this. Talk with those around you. Make sure you got this. Okay, whisper, whisper, whisper. What do we think? From 0 to 2. He's saying that the rate of change is decreasing from 0 to 2. Agree with that? You're giving me some funny eyes. What do you think? Before and after it curves? After it hits the minimums and maximums, the rate is decreasing. I guess this is a good question. Yes, sir? Negative infinity to 0. So wherever the accumulation is decreasing, the rate is decreasing. So in the same interval, the rate is decreasing in the same interval. Yeah. The rate. Okay. Right? Right? So you can agree with negative infinity to 0, kind of? He said negative infinity to 0, or something like that. Where we can see it. Okay, where is the rate? So let's just go one by one. Where is the rate becoming less positive? Well, the rate is positive wherever f is increasing. So where is it increasing and getting the rate getting less positive? So it's increasing here and it's increasing over here. Where is it getting less positive? Here, right at the beginning. The rate is positive because, why? Because the graph is going up, but it's getting less positive. Because our rate of change is decreasing. That's the very first thing we said. We said that the rate of change is getting, watch it, at the beginning, watch, ready? Here we go, ready? 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The rate's getting less positive, so the rate is decreasing. And then the rate is, here, getting more negative. So is it increasing or decreasing? Still decreasing. Where does it start to increase again? Somewhere around 0. Somewhere around 0, the rate gets less negative and then more positive. Can you see that? So the blue line is there to help you, the rate of change. The rate of change gets less positive at the beginning. Here the rate is getting less positive. Do you see that the rate of change gets less positive, therefore the rate is decreasing? And then we get to that maximum, and then the rate is getting what? More negative. So the rate is still decreasing until somewhere around 0, and then the rate gets less negative and more positive. So the rate, we'll do this in red, the rate is decreasing all the way to, you guys said 0, that's fine, so we're close to 0. So here R is decreasing. Because the rate gets less positive, and then it gets more negative until here. So all through there, the rate is decreasing. Now, what can you say about the accumulation wherever R is decreasing? So what's happening to the accumulation when R is decreasing? Let's start, I want to do something else before that, hold on. So if R is decreasing in this interval, what can you say about the rate of change of R and the graph of F? What can you say about the rate of change of R and the graph of F? So in this interval where we say R is decreasing, what's true about the rate of change of R? Notice, the rate of change of R. R is already a rate of change function. Can we talk about its rate of change? Sure. Okay, now we're talking about the rate of change of R. And then what can you say about the graph of F? Give it a shot. Go. Talk. Okay, what about the rate of change of R, where R is decreasing? What about the rate of change of any function when it's decreasing? Then the rate of change is negative. So we're going back to applying this thing. Wherever a function's values, if the rate of change, what can we say about the rate of change if it's decreasing? So R is decreasing. Whenever a function's values decrease, over here, the rate of change is negative. So the rate of change of R is negative wherever R is decreasing. Right? It's the same principle we talked about at the very beginning. It's just now that our original function we're talking about is our rate function. Doesn't matter. If the rate function decreases, its rate, the rate of the rate, is negative. Right? What about the graph of F? So what do you see about the graph of f here as the rate gets less positive and more negative? What's consistent about the graph? Can we say that the graph is, the accumulation is increasing or decreasing for sure? When R is decreasing? No, it does both, right? Here the accumulation is increasing, here the accumulation is decreasing. But what, so we can't, if R is decreasing, we cannot say that the accumulation is necessarily increasing or decreasing because we see both cases right here. But what can we say about the accumulation? What do you notice? Do you see that it's always, what, turning down? Whether it's going up or going down, it's always turning down, right? Or turning clockwise, right? You see that through this whole interval that f turns clockwise? It's turning clockwise like this. The rate is getting less positive and more negative. Your accumulation is always, it's like turning clockwise. Okay, and there's a name for this. It's called concave down. When the rate is decreasing, your accumulation is concave down. Like a frown. Right? Doesn't mean you have to frown about it, but it just helps. Concave down like a frown. Okay? All right, so then what about over here? Blue. The rate over here is doing what? Rate is increasing because it's either becoming what? Nope. Less negative or more positive. So, and what do you see about the graph of, so if R is increasing, what about the rate of R? What about the rate of the function R? Positive. If R increases, then its rate has to be positive. So the rate of R is positive all through here. And F does what? F turns counterclockwise, right? And we call that concave up. Who's going to beat me to it? Like a? Smile is nice, but it doesn't rhyme. Cup. Okay? Hey, you know, just trying to do whatever helps, right? Whatever helps, okay? Okay, so we've got, there's lots of things going around here, but most of it comes back to, like I said, these two statements. Wherever a function's values decrease, its rate of change is negative. Wherever a function's values increase, its rate of change is positive. And so we saw that, we applied that to accumulation and its rate, and now we're talking about applying that principle to a rate, and it's like a function R, and its rate of change, the rate of change of R. It still holds, okay? All right, so let's practice, see how we do here. Can I erase? Any questions on this? Okay, so new example. All right, so here, I need to make it bigger. So I'm going to choose an x value here of negative 3.65. Okay? And I'm just going to show you, so here we got some function, accumulation function. Its rate is called R1. And now look at this. What is R2? The rate of the rate. The rate of the rate, which we started talking about in the last slide. Okay, so this is the rate of the rate. And I'm going to show you that at x equals negative 3.65, that R2 function is about 10. It's essentially 10. Okay? So, what can you conclude about R1 from the information that you have? Okay? And then what can you conclude about F? All right? Something's wrong. Well, shoot. Okay, just kidding. Why did that not change? Hold on. Oh. There we go. Okay, sorry. Negative 10. All right. So, at x equals negative 3.65. Okay, so still got some more stuff to do. So, please control the restlessness, okay? And focus. Keep focusing. So, when x is negative 3.65, I'm telling you that R2 is essentially negative 10. Essentially, R2 is negative 10. Based on that value of R2, what can you conclude about R1? And what can you conclude about F? Talk. Go. If anything. Okay, so here are some choices for 1A, for R1. Positive, negative, increasing, decreasing, no conclusion. So if you know that the rate of the rate is negative 10, and what can you conclude about the rate? I hear people saying decreasing. Good, that's what's true, right? It's decreasing. Okay? That's right, it's decreasing. So therefore, if R1 is decreasing, it's either getting what? Less positive or more negative. What can you conclude about F? What can you conclude about F? I told you that R2 was negative 10. Can you conclude that it's increasing or decreasing? Could it be increasing? So we know the rate is decreasing, right? We know the rate is decreasing, but that could mean that the accumulation could be increasing or decreasing. But what can we conclude about F at negative 3.65? Turning, concave down or turning clockwise. We only have one value, so for a moment at that, it's turning down, or it's concave down. Now I'm going to give you some more information here. So now I'm going to give you R1 of n. All right. Now I just gave you, for the same value of x, I also gave you R1. So now you've got more information. What can you conclude about F? What can you conclude about F? I gave you R1. It's about 12.2. So they're saying increasing. The rate, what? So the rate is positive, and the rate of the rate is negative. So that means that the function is positive, and the rate of the function is decreasing. So this tells us that what? The function value is, function values are increasing. This tells us that the rate values are decreasing. It goes back to this every time. So draw it with your finger. Around negative 3.65, what does the graph look like? Draw it with your finger. See some different things, but you should be drawing this. This tells us that the accumulation is increasing. This tells us that the rate is decreasing. And that would be increasing concave down, like this. Okay? Okay, quick, let's do it again. Okay, so now I'm going to move and make x 4.2. 4.2. Do it again. All I'm giving you first is R2. So what do you know at x equals 4.2 if I just give you this value of R2? Go. Okay, what can you conclude about R1? In or D? Decreasing again. We got a negative rate of change, right? So decreasing again. Therefore, R1 is getting either less positive or more negative. If the rate is decreasing, it's getting less positive or more negative. What can you conclude about F? The only thing you can conclude is what? For that moment, around x equals 4.2, it's turning clockwise. It's turning down. That's all you know. You don't know if it's increasing or decreasing. You just know that the graph is turning down, turning downward. Okay? So now I'm going to give you R1. Go. So now you have R1 and R2 at x equals 4.2. Go. So what is R1 doing? Is it getting less positive or is it getting more negative? Has to be getting more negative. And what about F? Draw it with your finger. Draw F with your finger. Not everyone. No, so most of you got it, but some of you didn't. Okay? R1 is negative. That means it's going down. It's going down. And then the rate is getting more negative. So what does that look like? No, it's going down. Some of you, it's going down, and the rate's getting more negative. More negative. Like this. So, increasing, but the rate is decreasing, then decreasing, and the rate is still, listen. Increasing, and the rate is decreasing. Now decreasing, and the rate is still decreasing. So the rate is decreasing this whole, anyways, at those two values, decreasing. Okay, quick overview. This will be quick. Maybe. The right one. Nope. Okay, so here we go. So if we take the rate of change of the rate, the derivative of the rate of change is the derivative of the derivative. We talked about that today. This is called the second derivative. The second derivative. So all the stuff you did for the mastery test, okay, listen up. Because every time I have to stop like this, it takes longer. So just listen. Okay? Everything we did in the mastery test was for the first derivative. So now if you have a rate function, you've taken the derivative and then you take a second derivative, right? That's called the second derivative.